So what is the purpose of having concave mirrors and convex mirror? Well, their shape is a bit weird, and the image that they produce is not the usual object that you see. It might get squished a little, or it might get expanded a little. So why do we need this kind of mirrors then? So to do that, you need to look into the application of these mirrors.
Well, I think this is one of the most common convex mirror that you see. So this convex mirror is placed usually at shops. So you use this convex mirror to actually prevent shoplifting. Well, this is a convex mirror. Why? Okay, because if you use a convex mirror, you are able to diminish the size of the object. The size of the image here will be smaller than the size of the object itself. In that case, everything here will be smaller than the real object itself. What's the benefit of doing that? You are able to squeeze in more objects into the mirror. The mirror has a finite area, but by squeezing the size of the image, you are able to squeeze in more information inside one mirror itself. So in that case, you can say that this mirror here has a greater field of view. Greater field of view is that you are able to capture wider area of the space that you're reflecting off. In that case, one mirror here is able to take care of more area in the real shop itself. Okay, if you use a plain mirror, then probably you'll be reflecting off only a small area of the shop itself, which we don't want. We don't need to know the distance between you and the object very clearly. That's not our concern. Our concern is just to see whether there's anyone picking shoplifting from your shop. So in that case, you want as many details, but the distance between you and them, that's not our main concern. That's why I use a convex mirror. Another one application of convex mirror is you might see these kind of mirrors being placed on your side mirror. The side mirror is usually a plane mirror, so the image that you see usually have the same size with the object itself. It's usually, okay, there's convex mirror for side mirror, but it's usually a plane mirror. So the problem with plane mirror, as we said just now, is that it has a limited field of view. You cannot cover a great amount of field that you are trying to reflecting off. In that case, sometimes you have things called blind spot, which sometimes motor pass by the car, but you're not able to see it through this side mirror. So people usually install this, what we call it blind spot mirror. So this blind spot mirror here is a convex mirror, and because it's convex mirror, it's able to fit in more information inside the limited area of the convex mirror itself. In that case, you are able to see spots that you previously cannot see through this plain side mirror itself. So people usually install this to be able to check whether there's anything being placed or traveling beside you around your blind spot. Okay, so that's one of the usage of convex mirror. So we have done theory, we have talked about a little bit of application. So let's try and apply what we have learned in the question. Figure 1 shows an object O, this object over here, placed in front of a concave mirror, where the C and the F are the center of curvature and the focal point respectively. So in the question 1, they ask you to copy figure 1 and construct the ray diagram for the formation of the image. Well, this is figure 1 and I've copied and pasted it here. So now let's try and construct the ray diagram to determine where is the image of this object over here. Well, to construct a ray diagram, it's always the 3 steps, the 3 different rays that you can draw. In your exam, being able to show 2 is good enough to obtain marks, but I highly recommend, if it's possible, please draw 3 rays, because that helps you to double check whether your first 2 rays are in the correct direction or not. Okay, so the first ray will be parallel to the optic axis, coming out from the top point of the object, parallel to the optic axis, then get reflected back in the direction towards the focal point. Okay, so something like this. Coming out from the top point, parallel to the optic axis, then we get reflected in the direction that is going towards the focal point. So we also extend this reflected ray backwards as well, just in case you need it. So it's important for us to label the direction of the ray, or else it is considered incomplete. So make sure you label the direction is going this way, then it get reflected this way. Until this point, only you can consider your first ray to be complete. Okay, then the second ray will be in the direction that is through the focal point. So it's in this direction through the focal point, but the ray itself comes out from the top point of the object. So the ray actually starts from here, going up here. Okay, where if you trace back, this direction is actually along a line that passes through the focal point. Then it strikes the mirror, then it will get reflected parallel to the optic axis. So something like this. Okay, so this line here is just a projection of the incident ray backwards to show that it is intersecting with the focal point. You need to draw this to show that it is coinciding with the focal point, but it is not a ray. It's just to show the direction is along the line that passes through the focal point. This is where your ray starts. So your ray is along this direction, strikes the mirror, and because you know this incident ray here is along a line that passes through the focal point, you know that the reflected ray is parallel to the optic axis, just like what is drawn over here. Again, you extend the reflected ray backwards in dotted lines. Again, we still need to label the direction very clearly. So label the direction over here, striking a mirror incident, then after that reflected parallel to the optic axis. So this is what you draw for the second ray, and if you stop here, then you are able to determine the image to be here already. But as I say, it's better that we draw three of the rays to double check whether they are all intersecting at the same point or not. Okay, so the third ray will be a ray that is in the direction along the line that passes through the center of curvature. So it will be along the line that passes through the center of curvature somewhere here. Then you start from here, you strike the mirror, then you get reflected back along the same line passing through the center of curvature. The ray starts here, then it strikes the mirror, then it reflected back in the direction that passed through the center of curvature, because your incident ray is actually along the line that passed through the center of curvature already. So the ray will be something like this. It starts here, incident, strike, then get reflected this way, and the reflected ray, if we extend it backwards, you see these green dotted lines, it actually intersects exactly at the point where the first and second ray intersect. Okay, we cannot stop here for the ray, we have to indicate the direction. So if incident this way, you get reflected this way. Okay, so now with everything labeled, we have determined the point of intersection to be over here. So we can label our image right now. So we label our image with an arrow pointing from the optic axis towards the point of intersection. Then we label it as I. Okay, so once you have reached this part, I think you can consider this to be a complete ray diagram. And we can move on to the second question, where we are asked to state the characteristics of the image. So to state, it's always real or virtual, magnified or diminish, then whether it's upright or inverted. Okay, so let's try and determine it. So the first one is state the characteristics of the image. The first one will be whether it is real or virtual. Well, the point of intersection, it's caused by three lines that are dotted lines. So these are not the actual rays. It's just that if you place your eyes around here, you see that the reflected rays, you can think of it as all originating from this point over here. Okay, this is just a projection backwards. You can see that they are all originating from this point over here. You perceive the ray to be originating from this point over here, but this is not an actual ray itself, it's just projection. If you place a paper right behind your concave mirror, you will not see any image being illuminated on the paper. Okay, it's in the mirror. If you see here, the image is in the mirror, so it's virtual. Okay, in that case, we can see that our first one will be virtual. And the second one is whether it's upright or inverted. Well, it's above the optic axis, so you can just write upright. And the third one is whether it's magnified or diminished. Well, the image is larger in size compared to the object, so you can say that it's magnified. Virtual, upright, magnified. So if you state these three characteristics, you've considered complete this question already. So before we finish off this question, just want to mention that real and virtual, sometimes you call it the nature of the image, whether it's real or virtual. Upright or inverted, we call it the orientation of the image, whether it's upright or it's inverted. The last one, we call it the size of the image, whether it's magnified, same size, or diminished. So it's important to know that these characteristics has a name: nature, orientation, and size. That's all for this question.